let me start basically very simple applications where we are using the geotagging, and which we did actually one of the largest private bank in India. So each of you basically, or each of us basically make transactions. Either we are withdrawing the money from the ATM, or we are swiping our card on the any merchant, right? And when we swipe any card or make any transactions online or otherwise basically, right, we get SMS immediately, right? Now that SMS has a very important information and has some location information also, at which merchant you have made the transactions and where that merchant is located. And precisely basically we use that information, the location and plus other information is stored in my Spatial database, that thank you very much for spending 2,000 rupees on so and so merchant and so and so location on so and so time, right? Now what we basically do, if you think basically that this SMS has a very powerful information. Now any bank, you are making these transactions on some merchant, the bank really can make a analysis of these SMS and can do upsell and cross-sell to you for other important basically campaigns, right? So for example, if I'm swiping a card of 2,000 rupees and so on, so location, now that merchant basically knows, oh, I visited basically that another store, food store. Now that food store can basically tie up with a bank, and bank can offer me 15% discount if I visit during the lunchtime, right? So how the spatial data characteristics are integrated seamlessly with the enterprise data, and we can create the value add things for the end customer, right? And as well as for the bank, right? So that's the power of geotagging data and the location information that you have, right? So in this talk, what I'm going to talk about, that some of the backend technology, that is the machine learning, the big data, right? How we make use of in creating or developing these applications. And as Professor Mukund said actually, that some of these libraries, and previous speakers also said in the opening sessions, that some of these libraries are already available, right, in different vendors' product, right? So I come from the data background, right? From like 30 years, right, my PhD, I've been working actually in the distributed databases, the big data, the autonomous systems, and so on. So I will give you the data perspective and the techniques perspective, then basically more on the geospatial data, right? So if you look at the database journey that we started, I mean, from relational databases to early 70s when the EF Code was working in the IBM San Jose lab, when relational database invented, since then basically we have done lot of work, right? In late 80s and 90s, we were using the enterprise data warehouse where we were collecting the information from different information systems, mostly structured data, and getting aggregated that information summarized, and that using that information for my decision-making applications, right? That could be with respect to my locations or with respect to other dimensions of the enterprise. Then in the late 90s or early 2000, people started realizing, hey, there is a value in the unstructured database. The structured database is only one single view of my whole organization. All the client or the customer's voice of customer's information is stored in the unstructured information, whether it could be a speech or whether it could be an email or whether it could be other kind of unstructured information. Why don't we basically make use of that information in conjunction with the enterprise structured data, right? And people started working on information integration. We worked basically a lot of work on this area, and I'll tell you basically how we are using some of the location information in deriving the value, particularly for identifying the churn and what area these churn are coming from in one of the largest bank in India, who are our referenceable customer, right? And then people started, here, now we get more data sources. We are getting data from different images, from different sensors, from my video feeds, from from other unstructured information, and they don't know how to make use of that information. So they were dumping all that information into the data lake, and then basically they developed some kind of agent, intelligent agents, which will figure it out that how to basically make some sense out of this data by correlating the entities, right, from these different data sources, right. And then now the trend which is going on now, and which is the future, is trusted information systems, the autonomous database systems, right. Autonomous systems means how we can make use of the AI or the machine learning, right, at the time of data ingestion, rather than basically somebody is building, you have already built the model on top of that and you are running the AI applications, right. You have built the model based on the data that you have seen. But if my incoming data characteristics are changed, then the model that you have built will no longer work on that, right. So how we can make the data, incoming data, when I say data, right, it's a very broad, right, whether it's a information or content or images or video or any satellite information or whatever, right, how we can make use of that data AI ready at the ingestion time, rather than basically wait to persist that data. Let's basically get the data collected and then somebody figures it out, what make basically some sense out of this data, so that build the model. By that time basically another incoming data characteristics changed, right. So how to make the data really AI ready at the ingestion time, to see the readiness, colon and uncolon, the readiness of that data, right, at the ingested time. And this is the piece of work basically that we are doing. And enterprise applications, basically they have seen the new applications, the 80% of your time goes actually to make the data curate, to make the data prepared for AI applications, right, or which are driven by the ML. And the blockchain, basically when you need the trust among the multiple parties executing a single transactions, you need a blockchain. So I will not cover that blockchain part here. So as you see, basically there are n number of applications. Professor Mukund Rao basically told several applications where we are generating or collecting the terabytes of data. These are some of the applications. Look at our Bharti, right? They have, I don't know, 200, these are the, I mean, few last couple of years old figures, but they have a 250 million customers base, and many of them basically are generating a missed call, and missed call basically generating a CDR. They are generating a terabytes of data, and then they know basically where this call is coming from, right, from which antenna or from which tower it is coming from, and they are analyzing that information, right. The important thing is they are collecting this big data, and big data basically has these three characteristics, right. All of you know. The fourth is basically the veracity, that the data that is coming from different channels, not all the data is really trusted, right, or completely clean, right. There is a lot of noise in data is there. So how we can create a trust, right, at the time of ingestion, if it is not trustworthy, because if you want to ingest that data in the enterprise information, it has to run on the trusted information. Otherwise, it's of no use, right? You make a wrong predictions, or you make a basically wrong campaign, and your clients may be unhappy, right? They might leave. So how to make the data which is in doubt, to make it clean so that we can really use that in the enterprise, right? Now the question is, what is the big data, right? So big data, if you see, basically it's a because I've drawn this into the 3 dimensions. So the machine learning community or the NLP community has done a lot of work, or they have been doing basically how to process a large number of unstructured information, right? Whether it's a video collections or the text documents analysis, and they consider very little structured data, right, or streaming information. Whereas the guys basically who are working on the event side or streaming data side, they have done basically how to process the streaming information, identify the events, basically make the complex or composite events, draw, basically see if there is an action needs to be taken for a given event whenever it happens. And the database community where I have come from, we have done huge amount of basically research which is there in the production in one or other form, how to process the large information, right, terabytes of information, right, designing a warehouse or any other systems. But the combination of this, right, makes the big data. That is, you get the information at a highly stream, some of the information is noisy, you have all variety of information in a large volume, how to process that information, right? So, therefore, basically we need a big data platform. And big data platform basically that whenever you have new applications which cannot be satisfied with your existing applications, that has new capabilities and you require new technologies to develop, right? And that's what our job of is there. Now, once we have this big data, let's basically look at, every speaker basically said the data analytics and the personalization, right? Today, you saw the industry 4.0 revolution is getting to the personalized services, right? And that's what basically all enterprises, they want to know more about you, right? What kind of transactions that you make, where are you, in which locations, basically what activities that you do, so that they can personalize the services for you, right? Whether it's a personal campaign or personal coupons or personal offers or anything, right? So if you look at the whole database journey that has been and now and going to be, is moving from system of records, from database terms, right, like in IBM DB2 or Oracle, to the systems of engage, how we can really get engaged, the interactive systems, the cognitive systems that we are building can understand our needs, right, so that it can give me the better services, right. So, different kind of analytics are there, from descriptive analytics to the cognitive analytics, and we have used various technologies over here, right. We started a machine learning even earlier also in the predictive algorithms, but now we need basically more sophisticated algorithms which are based on the deep learning and other technology, right, and analyzing the multimodal data, right. So if you look at this analytics, right, it can be done from anywhere, right? It can done right at your device level. The device is sending the information through gateways. You can analyze the information at the gateway, right? You can analyze the information, the edge or the network or at the whole cloud level. So it depends on my applications, what applications that we are looking for, right? So one of the things that we did with one of the bank here in India on the edge analytics. Edge analytics means the example that I gave you, when you make any transaction, you get an SMS, and when we at that edge itself, right, on the SMS gateway, we intercept that SMS and we analyze that email SMS at that point of time, and then basically make you the offer which is very highly personalized to you, right. So you can do this analytics from various data sources, right from device to the cognitive one. Right? So I'll just move that. Now I'll go very quickly on the machine learning part. Machine learning means basically that it gives the computers the ability to learn without being explicitly programmed, right? So if you look at it in the traditional way, what we give the data, we write the programs, program takes some input, data, and it generates the output. In the machine learning, what happens basically that we know what kind of outcome that we need, right? So we have trained the system, right? So on that trained data, so we give the trained data, right? We give the data and we basically identify the program which is the model. That's what the machine learning is, right? So when should we use the machine learning? When patterns exist in our data. Right, we know basically that the data that we have trained, there are patterns, we have developed the model, and therefore basically the incoming data following the similar kind of model, then we should use the machine learning. And there are various methods that I will come to that, right. We cannot pin down the functional relationship mathematically, right. Otherwise, if we know the existential relationship, then we can very well program it, right. When we have lots of unlabeled data, right, labeled training sets harder to come by, right, and this is what one of the some shortcomings in some of the applications, that we don't find enough labeled data, right? This is called the golden data. So we ask the experts, can you basically label this information, right? We like Google, basically Google has hired army of people to do the labeling, right? Whether it's our Indian festivals or whether anything, basically just go and they train this data, right? They label that data. Or reducing the multi-dimensional data to a lower dimensionality so that we can analyze in a higher level, and also other things, right? So let's basically see what is AI and ML and the deep learning. We hear basically this every day, and there is a lot of hype or reality basically to make my organization is an AI organization, right? All my applications, they are AI driven one. But AI has a different meaning to different people, right? So AI is a bunch of technologies, right? The AI which we learned basically during our graduate and undergraduate program was totally basically inference rule, reasoning, some production, some system, Mycin systems that we learned, and so on. So AI is more about understanding the data, do the reasoning from that data with respect to my other data, and learn from that, and then feedback to again, so that we can have a better understanding, right? And from that, basically, we generate a huge knowledge graph, doing the knowledge representation, whether it's a production tools or any other things. Perception, NLP, robots, machine learning is just one part, I don't know major or this, is one part of the artificial intelligence. And machine learning, as Professor Mukund also basically said, there are various methods, right? There's supervised learning, unsupervised, and reinforcement learning. And supervised learning basically is about that when you have the labeled data, right, and when you have already trained the systems, when you see the incoming data, when you see, hey, this incoming data has a pattern, my already trained data, then you can predict better, right? So regression model, right, doing for the curve fitting is the best one for the supervised, right? Then you have a unsupervised one. Unsupervised or predictive, the classification also is another example for the supervised one. Unsupervised one, when you don't have a labeled data, you have a huge amount of data. Look at basically, are there some homogeneous clusters in this data by different algorithms, or the KNN or other methods doing that. And reinforcement learning is through the example. You learn basically through the examples and then feedback on that, right? Deep learning is, now it is possible. When I was doing the PhD 25 years back, a lot of my friends basically doing the PhD on the neural network, and they were really finding very, very hard to find the computing power to train the system. Now, due to basically having a powerful hardware systems and the cluster of systems, this is now more materialized or realized one, right? So in the deep learning systems, you build this whole network, right, and you give any image or characters, recognitions or the speech, and then you can train the system. So like for example here, you can definitely say basically it's a dog, right? So you can train the systems and then take other images and then analyze those ones, right? These are some of the algorithms, but with respect to the spatial one, I'll come to that, right? So the main is that given a data, right? So you prepare the data, most of your time basically goes, as I said, how to prepare the data, right? And there are different ways, methods basically, or the steps to prepare the data. Then once you have prepared the data, then you choose the algorithms, right? You look at the applications that you are designing for, and then see basically whether you need a supervised learning methods or unsupervised or reinforcement. So you choose the right algorithm, and then you build the models, and then basically you run your applications on that, right? So with respect to the Geo ML, and this is from the S3, basically the slides I have taken here is that these are some of the tools basically that are given, and these are the models which are available over there, right? And some of the Geo ML library which is there, you can use basically some of the library. You don't have to make your own write a program. You just look at only the data, make the data ready giving to these models, and then you can run and build the applications, right? And more you can find basically these algorithms on the Wikipedia. The hundreds of them are listed over there, right? So let me go to the application. So one of the application after the Mumbai attack basically that we did, that identify this person given this, and by the way I have taken a fictitious names, right? So excuse me this. So identify this given a person, right? Whether this person whom this guy is related, track all his activities, on which locations he has traveled, right? Know everything about this person, and then whosoever basically based on whatever the rules they designed, and then identify a set of people who are closely and put those people in the tracking list, right? So given this person, we want to know who is this guy, where does he live. We find basically we interconnected all the backend data, as Mukund ji said, and there we find out, hey, Mr. X basically he lives in this particular location, then who is he associated to, we figure it out, and it goes on basically, and finally basically we go and put a tracker on this person so that basically he can be tracked, right, wherever we basically whatever we want to do that for that, right? The other applications that we are working on is very interesting, and he said the image analytics, and that is the really key of that, right? So without naming, a person basically traveled in 3 countries with these 3 different passports. Therefore, basically his coordinates were different, right? But his photos, right, was same. So none of these countries basically figured it out that this is the same person, right? So what basically we are doing, and we were given this, that given the image, right, and all of the database that you have, structured, unstructured, and all other ones, can you identify basically this is the same person and have traveled with a different identity to different location, and who are the people related to that? If someone basically comes to the airport and gives the address of this person who is in the tracking list, basically then connect that person to that, right? And with respect to the location and so on. So we did basically a lot of analysis on this piece of work, right? We did on similarly basically on that. This is really very interesting applications that we plan to build. We have basically some research prototype which we published in a top-notch conference as a demo paper. This is pay as you go. So as you know, this in India there are 56% cars which are not registered but they are on the road, right? For whatever the regions, right? So the idea here is that many of the cars, let's say in Bangalore you are working, you are traveling with the public transportation, but your car is in the garage, and you run that car, drive that car once in a week or once in a month, but you are still paying the comprehensive insurance. So can we basically develop some win-win kind of technique where you have to pay less insurance, but whenever you are on the road, you are completely insured, right? Even these guys, 56% guys who have not insured on that, right? So what we did basically pay as you go, which already exists, right? But the methods, current methods exist based on the number of miles or days or you want to travel. But what we did basically, let's say example he gave, you want to go from here to Vidhan Sabha, right? And you just say, okay, this is my source, this is my destination. There are different insurance companies that comes onto the network, and they say, okay, here are my quotations. Somebody say 5 rupees 62 paisa, 3 rupees 45 paisa, and so on. And each of them has a conditions. The 5 rupees say, okay, you are driving now. 3 rupees say basically, okay, if you travel after 10 o'clock and you take this route, which is not a narrow road, right, which is not a now congested road, you take this road, then it's a 3 rupees there. So they give you the different options because they know what is the speed on that road, right? They know the weather and so on. So you choose that, you start driving, right? And you sign basically, you say, okay, I fully agree on terms and conditions. And then basically that contract is written on the blockchain, right? Now you start driving, you say, hey, this is my outer ring road, which is now basically, let's say speed is 70, now you start driving at 80, right? Now system knows, so this application now, once you start basically exceeding the limit beyond some threshold, it start giving you the signal and say now your insurance has gone from 3 rupees 40 paisa to 4 rupees 10 paisa, because based on the basically what are the chances of the accidents and so on, right? Or you basically say, hey, my friend lives just 2 kilometers inside this road, let me go and have a coffee with him, right? So you break that contract, therefore your insurance goes up. So it's a dynamic pricing, right, based on the locations, your geo informations, your some of the dynamic variables, the speed, the weather, the routing and so on, right? And this is what basically the marketplace that we have been trying to build, right, for our Indian scenarios. And let's see basically that we believe that the people who are not insured and still driving the car once in a week, right, they have to pay less money, plus they are insured, right? And I have several applications like digital identity and so on, but given the interest of time, I'll just stop here, right, and then take the questions. But these slides will be available over to the conference organizers, and you will be given these slides, right? So with this, I'll just stop here, right?